Welcome. Today we're going to learn about the mean value theorem. First of all, we have to meet certain criteria. So if we start out, we have if 1, the function is continuous on a closed interval AB, 2, the function must be differentiable on an open interval AB, then there exists a C in the open interval AB such that the first derivative at C is equal to f of b minus f of a over b minus a. Now, if you look closely at this particular theorem, the left side of our equation represents an instantaneous rate of change, which is what first derivative is, and the right side represents an average rate of change. The average rate of change also is the same thing as saying basically the slope or the delta y over delta x. They're all basically the same thing. And I want you to keep that in mind as we move forward. So let's begin with an example. If we're given the following function, find the values of c where the instantaneous rate of change at c is equal to the average rate of change over the interval. So in 1, we have our function, and the interval we're referring to is between 1 and 3 on the x-axis. So in part 2, first we want to make sure that our function is continuous on our closed interval and differentiable on our open interval. In this particular case, since we have a polynomial, we meet both criteria. Now, there are times where you may have a function that does not meet them, and I want to just give you a couple of quick examples so that you know when you're faced with that. First of all, continuity. If you have a function with a denominator that at a particular value might be 0, then you're going to have a problem with continuity, assuming that that value is on your interval. When it comes to differentiability, a lot of times it's helpful if you know how to graph the function, because if you have a sharp turn in your graph within this interval, then that would be where it is not differentiable. Also, you want to look for vertical tangent lines to the graph. If you can do that, then you also have a problem, so long we're dealing with something within your interval. Fortunately, we do not have that problem, so let's move on. If you go to step 3, we want to evaluate the right side of the mean value theorem. And if you recall, it looks like what you see in 3. And what we want to do in our case, our A represents 1 and our B is our 3. Okay, A and B represent the endpoints of our interval. And if we evaluate them, f of 3, we're going to plug 3 into our function, we get 18. We plug 1 into our function, we get 4. B minus a is 3 minus 1, which is 2, and we get 7. In step 4, we need to evaluate the left side of our theorem, which is f prime at c. And that's simply the derivative of our function. So basic power rule, we take the derivative, we get 2x plus 3. In step 5, now we put the whole thing together. We want the left side equal to the right side, and that's our mean value theorem. And we want to have step 3 set equal to step 4. When we solve, which we do in step 6, we get x is 2. And that's the c that we were trying to find. Okay, so if you look at the graph on the next slide, you'll see this more clearly. So here is our graph of our function. And if you look at item 1 on the bottom, you'll see a heavy black line. The heavy black line is our graph, the graph of our function. And you can see on the x-axis, I've basically divided things up between 1 and 3. The little dotted lines move up to our graph. So you can see we're really only concerned with what happens between x is 1 and x is 3. Now, as far as our theorem goes, there are two sides to the equation, as you recall. On the one side, on the right side, we're looking at the average rate of change. Well, that has to do with the slope of the line that moves between x is 1 and x is 3. So that's our blue line on our graph, okay? And we want the average rate of change on our interval will be the slope of that blue line. Now, that is going to be in turn equal to f prime of c. Well, f prime of c is the instantaneous rate of change. And that, remember that slope is always the slope of the tangent line to our graph. So in this case, the tangent line, which is a line that only touches at one point, is our red line. In order for the slope of both the red and the blue line to be the same, they must be parallel. And you can see that they are in this particular case. And that red line intersects our graph at one point. And that's the point at 4. And the x value there is 2. And 2 is within our interval. And that is what we calculated using the mean value theorem. So that's the mean value theorem. Now go practice, practice, and practice some more.